Welcome back everybody to another Unity game dev tutorial series where today we're going to be sneaking around a military facility, avoiding guards and cameras in this Metal Gear inspired stealth game series. But before we do, please make sure to download the project from the link in the description so that you can follow along at home. So, when you're ready, grab your bandanas, let's crack on. Upon opening the project, you will see everything is prepared and ready to go, from the animations to the sprite work to the necessary game objects. We'll cover them on a need-to-know as we go basis, but feel free to explore what I've prepared here from the military facility made using tile maps, and we also have our player controller already set up. So let's go ahead and take a look at movement. You'll be able to control your character in 8 directions, and the animations are already prepared for you. If you'd like to know more about how to achieve this style of player movement, feel free to check out our video covering 2D player movement, both side-scrolling and top-down. But in short, we're basically using a animator blend tree that takes our input and then transitions between the necessary animation, and we'll explain this in more detail later when we discuss enemies. But as you may notice, we can walk around the facility. When we go through this passage here, we're off camera. So let's go ahead and set up a really good camera follow script. Simply go to the scripts folder, create your own camera controller or select mine, drag and drop it onto your main camera game object, then go ahead and open it up. Okay, so for the variables, we want to have a target for the camera to follow. So let's start by punching in public transform. That will be the player target, the transform we will follow. We also want a speed for the camera. So we'll have a public float called smooth speed, and let's set a default value of 0.1f. Now, while the camera is following our target, we also want the camera to be at a fixed position, which will be a public vector-free offset, and I will demonstrate why when we head back into Unity, why we need this offset. Additionally, we also want to clamp the camera to the boundaries of our level on the X and Y transform. So we'll have 2 serialized fields so we can view it in the inspector. First, we'll have a float minimum position X, max position X, and below exactly the same, but for the Y transform. Then let's head into fixed update. Alright, so in fixed update, let's start off with a vector free called desired position, the position we want our camera to be, and that will equal the player target.position plus that offset value we set in the variables. Then underneath we'll have another vector free called smooth position, and this will be a lerp, a vector3.lerp, between the transform.position of the camera and the desired position by the value of smooth speed. Then we want to update the transform.position of the camera to equal that smooth position. And finally, let's clamp the camera to the level boundary by setting the transform.position equals a new vector3, open up a set of brackets, mathf.clamp. So let's clamp the value on X, that smooth position.x will be between the min position X and the max position X. Then we'll repeat that again for the Y, mathf.clamp, open a set of brackets, smooth position.y, minimum position Y and maximum position Y. And lastly, we want the Z value to remain as it is. So we'll just set transform.position.z. Okay, hit save and let's head back into Unity. Okay, once the code has compiled, let's go ahead and fill in what we need in the inspector. It's asking for a player target transform, so go ahead, drag the player in there like so. We have our smooth speed of 0.1. I'm just going to change it to 0.2. Then I want to demonstrate why we have the offset here. If we go ahead and hit play, you'll see that the screen is black. That's because the camera is literally at the same position as the player. And you can see on its Z value here, it's going a bit crazy. Essentially, the camera is looking behind all these sprites and the level. So what we need to do is just change the Z offset to -1, and we can get a good view of the player. So let's go ahead and change that to -1, and we'll leave X and Y as 0. As for clamping the camera, the variables that we want relate to the X and Y transform of our level itself. If you want to find that out, the quickest way is to take your camera, holding down Control, and move it to the very edges of your level. To the left, mine is -18, which means it'll be +18 to the right. You can see that the camera is already at 0 on Y, so let's see what the top one is for Y. That'll be 20. So those will be the values I will input. So for my minimum X, that would be -18. And then for maximum X, that would be 18. 0 for the minimum Y, and then 20 for the maximum Y. So with those in place, let's go ahead and explore. Now we can move around and the camera is following us just like so. Let's go to the left of the stage here and see that clamp in action. There we are. So the camera has now stopped following us once we hit this corner, and will resume following us when we move upwards. That works quite well. And there we go, guys. We've created a nice, smooth camera following script, so we can now go ahead and explore this military facility, because next time we are going to look at how to add patrolling enemies using waypoints. Please do look forward to that. Thank you all very much for watching, guys. I hope this was useful to you, and I look forward to showing you the rest of this series. Take care and have fun. See you soon.